I'm going to start off with an introduction to similar figures. Particularly, we're going to be working with similar triangles. Before we get into any problems, we must understand what similar means. Similar figures, by definition, is when figures are drawn in such a way that they have equal angles but proportional sides. The symbol to indicate similar figures is tilde. That's a single slash mark, or what's called a tilde. Be sure not to use the double wavy lines because that means approximate. And with our first couple examples here, we're going to look at the idea of having the similar triangle, but we don't have any reference. We don't have any triangle to work off of. And so that can be a blessing and a curse. The blessing is that you can draw any triangle you want. The curse is that you have to make sure everything is oriented, that everything relates to itself. Example 1, when it says, finding missing sides for triangle ABC similar to triangle DEF when A equals 5, C equals 11, E equals 12, F equals 9. Round the answers to the nearest tenth. You have to make sure that you understand angle A has to be looking or in reference to angle D, angle B would be in reference to angle E, and C would be in reference to angle F. Example is specifically what I'm talking about. I'm just going to draw a triangle. This is my triangle. I'm going to call it A, B, C. Now in that same order, I must label triangle DEF. I'm not allowed to change the order. So this went base, summit, base. I have to do the same thing. So when I come over here, I'm going to make it smaller. It doesn't matter whether you make them bigger or smaller, but generally they're not the same size. They're in scale. They're in proportion to one another. And so then I go D, E, F. You see how I went in that same order? A, B, C, D, E, F. The second item that we have to learn about is the way that you label your sides. These are the points. These are called vertices to a triangle. Sides, most of you have probably said things like side AB, side BC, so on and so forth. But in truth, we can label these off of the vertex. If the vertex opens up to this side, instead of calling this side BC, I can say angle A opens up to little a. Angle B, or vertex B, opens up to little b. Angle C would open up to little c. In a similar way, I can come over here to this triangle and say this would be little d, little e, and little f. Well, I go back to the problem and I'm going to place the specific values. They're telling me that little a is 5, little c, I just like to say it that way, little c is 11, and then over here I can say little f is 9 and little e is 12. Remember, in algebra you can only relate one unknown at a time. So you can set up any proportion provided that you only have one unknown at a time. Example of what I'm talking about. As I work this first problem, I can say C is to B, so 11, because that was C, is to B, as 9 is to 12. F is to E, because it's the exact ratio. C is to B as F is to 12, or F is to E. And so I go 9 is to 12. Now to solve this, we can use the method that we've been talking about. You multiply by your common denominator. In this case, it would be 12b. As you multiply by 12b, this would become 11 times 12 is equal to, on this one the 12 drops out, 9b. And then divide by 9 and get an answer. As I divide by 9, I'm going to run out of space here. I would go 11 times 12, I'm dividing by 9, I'm dividing both sides here by 9, over 9 is equal to b. Then I can put that in my calculator. These shouldn't be problems that take very long. I go 11 times 12 divided by 9. I get an answer. Now my answer is in decimal form, and the directions said round answers to the nearest tenth. So as I look at this answer, when I round to the nearest tenth, I'd get 14.7. And so I'll say B is equal to 14.7. Now that gives me one of the answers right here, but I still need to find this other unknown. It would be a poor choice to use this answer because if I got this wrong and then I try to use that answer, it guarantees the next answer wrong. So I want to set up another proportion with known values. As I look at the triangle, I look like I can go with left is to right as left is to right. It only leaves me with the one unknown. And so I can say 11 is to 5. I'm going to try and work this out over here. 11 is to 5 as 9 is to D. Again, as I work this out, I would multiply by the common denominator. Common in this case would be both 5 and D. As I distribute, the 5's would cancel out, so this would be 11D equaling. I distribute to the second fraction. This time the D's drop out. 9 times 5. Yes, I know 9 times 5 is 45, but I'm going to let the calculator do all the work. My next step is to get the variable by itself, so I simply divide by 11. And so I type that into my calculator. 9 times 5 divided by 11. Again, I was supposed to round my answer to the nearest tenth, so as I look at this, this says 4.09 to the nearest tenth. I would say 4.1. 4.1. And as simple as that, I've solved similar triangles to find missing sides.